Okay, so in this question, a ball of mass m when dropped from a certain height strikes a wedge kept on a smooth horizontal surface and the ball moves horizontally just after impact. If the ball strikes the ground at a distance d from its initial line of fall, determine the amplitude of oscillation of wedge after being hit by the ball. So we need to calculate the maximum displacement of the wedge in this direction because that will be the amplitude. Okay, so here let's assume some variables. So when the ball is hitting the wedge, okay, so let's assume that the velocity of the ball just before hits it is u, and when it hits the wedge, okay, and after hitting it goes horizontally. So let's say that velocity is v1, and after hitting it the wedge will also move in horizontal direction, so it's, let's say its velocity is v2. Okay, here we have this height h, and it says that the horizontal displacement is d. So first of all, from projectile motion, like we can write the value of v1. As we know, this is like basically projection from height, so we can say that the formula d equal to v1 root over 2h upon g. So from here we can say that v1 is nothing but g, so if we square basically, so if we square here, gd square by 2h. So this is v1 square. Okay, so let's see here like where we can use this one. Okay, now, and one more thing, we can say that when the collision is taking place, okay, so like during collision, like there's no external force acting in the horizontal direction, right? So F external is 0. Sorry, F external is equal to 0 in horizontal direction, right? So we can apply the momentum conservation. So we know like if F external is 0, so momentum of center of mass is going to be constant. Okay, so that is constant here in horizontal direction. So the momentum of the ball, okay, that will be in horizontal direction. So that is like the mass of the ball is m, okay, that is given. So mv1 will be equal to the mass of the wedge, which is capital M, into v2. So that is the equation we have. So now from here, from this equation, we can calculate v2, right? We put this value v1 here and we get v2. Okay, now we need v2 only because now we can apply work energy theorem, the energy conservations basically. If we apply work energy theorem on the wedge, so the wedge has velocity v2, and with this velocity v2 it will compress the spring, and let's say the compression the spring is x maximum. So this half mv2 square energy, kinetic energy, will convert into the potential energy of the spring. So half k h square, and this h is the amplitude of its oscillation, right? So half get cancelled here. So h is equal to v2 m by k, right? And what is v2? v2 is m by capital M, v1 m by k. Okay, and what is v1? So this is v1 here. So h is our amplitude, so capital A, so m by capital M into v1 is d root over g by 2h into m by k. Okay, think I made a mistake. Okay, this mass is the mass of wedge. Okay, so basically this is capital M, this is capital M. Okay, so wedge mass is capital M. Okay, so now this root m here, this m here, so obviously there will be a root. So I'm writing root terms together and the terms without root. So terms without root we have md, okay, and we have this. So here we have md by capital M, okay, and in root we have g capital M by 2hk, and this is the answer. Thank you. That's it.